Hello all. I, Article welcome you all to the second part of the Bridge course in Information Technology organized by the SIES Nerul College of Arts, Science and Commerce, and my topic is Algorithm and Flowchart. In the first part of my sessions, we saw what is the relevance of algorithms and flowchart in programming. We looked at the different components of flowchart. Now, we will look at various examples as to how to solve problems, how to write the pseudocode algorithm, and how to draw a flowchart for a particular problem statement. So let's start with the first example. So the first example is write an algorithm and draw a flowchart that will make two sides of a rectangle and calculate its area. Now see, whenever we are doing programming, in the beginning you will be getting such simple sums or such simple problems to solve. Like you will have to write a program for a computer in some programming language where the computer can automatically calculate the area of a rectangle. So as you already know, the area of a rectangle is width into its length. So basically, we need the user to input the width and length. Now, see, the thing is, there are two ways in which this can be solved. We can initialize the value of the width and the length of a rectangle. Like say for example, I can say that the width of a rectangle is 20 and the length is say 10. So I can say W is 100, W is 20 and L is 10, and then I can calculate the area as 20 into 10. That is what you must have done in mathematics when you were a student. Now when you're making the program do that, you can do it in that manner where you can initialize the value, you can set the value to variable, width ka value is 20 and length ka value is 10. The problem with that approach is that then your program is not of much of a use, because the idea behind writing an application, as I said, is to reduce the human error, sorry, not human error, sorry, human efforts. Of course, error is also reduced. Like when you're doing the calculation as a human being, you might make mistake in multiplication, whereas a computer will never make a mistake in calculation. Okay. Now, when you're looking at any program, the best way is always to take the input from the user. That is what makes your program much better. Like for example, if you purchase a calculator. Now, when you purchase a calculator, it has number keys on it. Now, using those number keys, you can enter any number of your choice, and then you have different operations which can be performed on that number. Now, if I ask you a question, would you purchase a calculator which can perform only fixed set of fixed set of operations, like it can only add 10 plus 10? Will you like that? No, you will not. You would like to have a calculator which can add any number of your choice, and that is what a good programmer does. A programmer will write a program logic which should work on any input given by the user. When I say any input, do not mistake it for anything. It means that any relevant input. So like when you are looking at a program like this, write an algorithm and draw a flowchart which will be used to calculate the area of a rectangle. The pseudocode, as you know, pseudocode मैंने आपको कहा था, it is just something, it is a program logic which is written in simple English. So when we were students, we knew that the area of a rectangle is length into width. So in the pseudocode, I will simply write it as input the width and length of a rectangle. Second step is calculate the area A by multiplying length with L with W and print it. This is my pseudocode, which is very simple to understand. It is in simple English. Now we move on to the next part. Now see, the pseudocode which was written in the previous slide is now converted to an algorithm. I told you an algorithm is very specific. So you can see right now in front of your eyes, the algorithm is very specific. Now this algorithm has 3 steps: input W, input L. Okay, step number 1. Step number 2, A is Now see, in a flowchart, whenever you're writing an algorithm, they do not write equal to sign, they usually write this arrow. So A is calculated as L into W, and step number 3 is print A. So that is how you write an algorithm. Please note the difference between the pseudocode and the algorithm. See, the pseudocode is simple English words. You are writing sentences which anybody can understand. An algorithm is specific, where we talk about the variables. W and L are called as variables in programming. Variables are um, strings, or they are something. They're memory locations which hold values, which store values. Okay, so there are two variables, W and L. So W नाम का एक वेरिएबल बना आपने, L नाम का एक वेरिएबल बना है. यूजर whatever input the user gives, the first input will go to W, the second input will go to L. Okay, and step number 2 is performed by the computer, and step number 3 is also performed by the computer. So that is your algorithm for calculating the area of a rectangle. Now let's have a look at how does the flowchart representation of the same algorithm look like. So on the right hand side of your screen, you can see that we have a flowchart which starts with the start symbols. You can see that you have a square with rounded rectangle with round edges, which is for start, and stop. See, look at the similarities. If you remember in the flowchart symbols in the previous session, start and stop symbol is similar. So they are geometric figures. You can see start, stop is written in that. Next, if you remember, a parallelogram was for input. So we have written start is the first step. You start your program. Second step is to input W and L. So because it is an input, we are using a parallelogram. Third step now is calculating the area, which is length into width, and then finally we are printing the value of A, and last step is stop. So remember, whenever you are drawing a flowchart, it should always have a start and stop uh, state. Okay, and look at the way it is drawn. Make sure that you use the right symbols. And if you just saw the entire flow now, if you just notice the entire flow, एक प्रोग्राम था जिसमें we were supposed to calculate the area of a rectangle, and as a student or as something that I've read or from some knowledge that you get, you just somebody is going to tell you that area of a rectangle is calculated as length into width. So ये जो logic है, somebody has told you कि area ऐसे calculate होता है. Now as a programmer, what you got to do is you have written the logic that somebody told in pseudocode. Okay, so मुझे पता है कि मुझे area calculate करना है, तो मुझे दो चीज़ लगेगा, length and width. So which means that I'm supposed to take the input from the user. So input दो चीज़ों का लगा, length का और width का, and then I have to calculate the area by multiplying length into width, and then I have to display the area to the user. So that is how you think of solving a problem. So you take a problem, you break it down into simpler steps, write it in simple English, that is pseudocode. Then you can write it in an algorithm, and then finally you can convert it into a flowchart. Now see, it is not mandatory that you use all three of them, because we are learning it in the initial stages. So to understand how programming goes, and then of course we'll be referring to a lot of books. So every book has its own way of solving problems. Now flowchart is just a representation which is usually used in project documentations whenever you are making big softwares which have a lot of programming in it. In that case, to understand the workflow, we have a flowchart. Algorithms are basically used to represent as to what are the steps that will be taking. So some people might skip the pseudocode and they might go directly for the algorithm. And most of the times people have an algorithm written and then they code based on the algorithm. Coding is something that I'm not going to teach today because that is part of your curriculum, and your respective faculties will teach you how coding is done. Okay, so that is about the first example of programming. Let's look at the next example. Now here we have an example which is used to convert. We are supposed to write a program to convert the length in feet to centimeter. So किसी ने आपको जो वैल्यू है वो फीट में दिया, आपको सेंटीमीटर में कन्वर्ट करना है. So feet, as you know, is 1 feet is 30 centimeters. So since we know the logic, I have written the pseudocode. Read the input length in feet, calculate the length in centimeter by multiplying whatever input the user has given with 30, and then you print the output in centimeter. That is the pseudocode. The algorithm is again very simple. Step number 1, input the feet. Step number 2, calculate or convert the feet to centimeter using the formula that feet into 30. Feet का जो भी value user ने दिया, and finally step number 3 is print the length in centimeter. So if you look at the flowchart again, it is quite easy to understand. You have the start state. Further, you take the input, which is put in a parallelogram. Then you calculate. This is a process. That's what I said. Calculation is a process. That's why it is written in a rectangle. So you're converting the feet to centimeter with the formula which is already pre-established, and finally you print the LCM. Okay. Well, I think we'll stop here.